Hello, this is a video walkthrough of exercise 5. Um, in this exercise, we actually get to use Kali and do some reconnaissance on our uh, system that we've built over the last couple exercises. Um, so as you can see, I have my traffic light exercise up and running, exercise 3. Um, And I also have my Kali box that I set up in exercise 1 um, up and running too. So to log into the Kali box, the username is Kali and password is also Kali. First thing the exercise wants us to do is to run nmap on our network. Um, and so to do that, just type in sudo nmap dash sn and the subnet, which is 10.0.2.0 slash 24 forward slash, that is. Nmap is able to detect what hosts are up and running on a network, as well as any ports that are open and services that are running on those said ports. This one was just a simple tell me what's running, or tell me what hosts are up. Um, and so these two at the top, um, everyone I've asked, everything I've looked up, I'm not sure what these two are. Uh, Probably something to do with using VirtualBox. Now, these three right here are what we want to know. These three are our boxes that we are using to run this traffic light exercise. So for me, um, this dot 4 is my HMI. The dot 5 is my um, PLC, and this dot 11 is my Kali box, what we're on right now. um, so this information right here is what you are going to be using to fill out the 6.1 chart. Um, so this is just a basic scan of tell me what hosts are online and available for the network. To run a more detailed scan, we're going to want to run the command sudo nmap -s capital T -p, and we want to give it ports to scan. So I just took what was done in the video that was shown over one of the lectures and did 100 to 10,000, and with the same IP subset or IP set. And this should take about a minute. Okay, so now that is done, um, we can see the three boxes that we really care about. We have our Kali box down here. We have our OpenPLC right here, and the HMI right here. Um, and so as we look on what for what services are running, um, we can see this 9090 port is our HMI, and this is what is currently running the SCADA BR site that we see here. Now, this AGP13 is another service provided by Tomcat that we don't need to have up, and so we will close that in a second. Um, but here on our PLC box, we can see on port 502, we have this MBAP service. This is our Modbus. Um, So this is what is actually communicating to our Arduino board. Um, and then we have on port 8080 our HTTP server that we're running, um, which is the OpenPLC site that we use to launch all of our programs. So now we're going to go and close um, this 809 or 8009 port that is on our HMI. So the way we do that is through IP tables. So sudo IP tables dash capital A all caps input dash P TCP dash dash destination dash port, and this is 8009 8009 dash J all caps reject. As you can see in the documentation for this exercise. So if you run that, no problems. But if we were to go ahead and run another port scan, we would still see that the 8009 port was still open. And the reason for this is the way Nmap scans. So it throws its packets at all the ports that you specified to run on. And if it times out, it'll see it's closed. There's nothing running on there. But we've set this IP tables to reject it. Um, and so Nmap sees that its packet was rejected, and so it reasons that, hey, there's something running there, it just won't let me through. And so that's why you won't see any change on your scans. Um, so now this information is what you will use to fill out the 6.2 tables. And on the tables, the node is just what box is it? Is it the PLC? Is it the Kali box? Is it the HMI? Or if you're on Mac, is it the pseudo host that you're using or the faux host that you're using? Um, so now we want to install smod. And so how we're going to do that is we're going to clone a Git repo. So we're going to go sudo git clone https github the the Ralph Brown smod-1. So I already have it. It shouldn't take too long. But we're going to go ahead and go into the folder that it creates, smod-1. Um, and then we can run Python smod.py. This is different than the documentation, um, just by the dash that it says, but it's only just smod. So now we are in the smod program, and if we type show modules, it shows everything we can use um, with this program. So we can we can write single coils, single registers, we can read coils, read registers, all kinds of stuff. And so now we want to use modbus slash scanner slash get function. So now we are kind of in the function. We want to show options. And these are all the options we can change for this function. Um, so as you can see, these are the current settings right here. And these are a status of what is required. So for the get function, we need uh, the rhost variable and the UID variable. And that's all we really need. Um, so to actually change or set these variables, we go set rhosts, and we want to set this to our um, OpenPLC box. So for me, that is .5. And then set UID to 1. So if we go and show options again, we can see that our host is now 10.0.2.5 and UID is 1. So now we can actually go and exploit, type in exploit, hit enter, and we can see all of these functions that are supported um, through our server. So as you can see, we can read coils, we can write to single coils, holding registers, all of this stuff we can actually do. So now let's see what we have in our holding registers. So if we use modbus slash functions or function read holding register and show options. So again, we need an rhost, a UID, as same as the last one, but this one also requires a starting address and a quantity. So this is just identifying where to start reading data and how many it needs to go before it stops. So if we go over into our SCADA BR and into data sources and edit our exercise 3 and go down and into this top right module modbus read data and drop down to holding registers, and actually we can go in and see um, where we store it. So the lowest one is 1024. So off base 10, 10, 24, and do 6 registers because we only have 6 lights, so 6 timers. And there we can see um, all of the registers holding our times. Um, so let's go back over here. We set our hosts to 10.0.2.5, set UID to 1, and these numbers for our starting address and our quantity are in hexadecimal. So if you don't know hexadecimal, then you can just easily go over here to 1024 to hex. And it handy dandy spits out the hex value. Um, so set start address to 0x0400 for 1024. Oh, and oh, I misspelled the variable. So it kicked me out of the function. So, okay. So set start address 0x0400. There we go. And then set quantity 0x0006 because there are only 6 holding registers, one for each light timer. Okay, so if we show options we can see we have our quantity is 6, our hosts is our PLC, and our starting address is the hex value of 400. Um, so then we can go ahead, and I would recommend having this handy dandy. And as soon as you actually run um, the command exploit, go over here and read so that it has as most accurate data as possible. So here are our registers. And at the time that we ran the command, um, so these are the values that we care about. Right here, the register val. And in holding registers, it uh, it stores them in tuples. So these two numbers are for the first register, and I'm not sure what this first number means, but the second number is what we're actually looking for, so 5. So at the time, 0, 10, or 1024 had a value of 5, and the second one had a value of 10, or A in hex, and the third had 5, fourth had 5, and fifth had actually a timer of 0, and 6 had 5. So now, what if we could read what each coil was valued at? So if we use modbus slash function slash read coils, oh, and show options, here we can see what we need. So we need a quantity, the host, um, a starting address, and a UID. This will be slightly different, and I'll explain why when I get to it. So set our hosts to 10.0.2.5, set UID to 1. If you followed my exercise 3 um, guide and you split the registers up into two sections, um, for me, it was one set of lights had registers 0, 1, and 2. The second set of lights had registers 801, 802, and 800. Um, if you split them up sort of like that, or anyway similar to that, then um, your quantity will not be 1. Um, and your starting address, depending on where you started storing, will be wherever that is. So um, for me, since I started at 0 and I ended at um, 802, if I go and search 802 to hex, so set quantity to 0x03 to 2. So we can see here that it'll search this host on this port, starting at this address for this many. So then, again, I would go ahead and change this to coil status, and let's just do 0 and 3. So run the exploit and read the data. So here we can see that for me, 0 is the red light, 1 is the yellow, 2 is the green. So how do we interpret this data? So this is the values stored in the coils. Um, and the way that Modbus runs, it stores registers in 8-bit numbers. So registers 0 to 7 are stored in this one number as a binary number because coil status can only be true or false, or 0 and 1. Um, and so register 0 will have the rightmost bit place in this number. Register 1 will have the bit place directly adjacent to the left of register 0. And so based on this number, we can determine that register 0 is true and nothing else is true in those other 7 registers. Whereas over here, this is a 4. And so we can determine that the third register, or register 802, is on or true, and nothing else in those 8 bits is true. Um, and so the reason why this is so spread out and there's so many zeros is because I split them up like the way I did into 3 segments. Um, it grabbed 8, and so obviously these 3 are way more than 8 apart from these 3. Um, and so the only way to actually see them on the same screen is to search all 802 of those registers. Now, if we were to actually have combined those registers and stored them in the same set of 8 registers, then we could have something like this. So here, I changed the quantity to 3. So it only searched the first section of 8, the rightmost 3 bits. And so that added up to 1. And so, like before, we can determine that the rightmost bit was true, which mapped to our register 0. And so that tells us that the red light was on. So the next part of the exercise goes into a site called Sodan, um, which is just this website, sodan.io. And this actually is a search engine for anything that's open on the web, um, like port-wise. So if we were to search Modbus, we can see that there are 310 things related to Modbus. And this is used in the post-exercise report. So this does it for the demonstration for exercise 5.